Again, welcome to CS628 class, Data Science using Python. This is our Unit 1 lectures, Introduction to Data Science, which cover our course textbook, Chapter 1. So our main objective in these lectures is to go through what is a data science, why data science, also data science methodologies and tasks. So here we say one of the fastest growing fields in the world is data science. Demand is expected to increase in the future. And the number one reason why data science remains the top job in America is the shortage of talent. So data science is an interdisciplinary field about process, systems to extract knowledge or insight from data in various forms, either structured or unstructured, which is continuation of some of the data analysis fields such as statistics. Now, with statistics, we normally use a structured data and a very small data, which we normally call the sample. But in terms of data science, we can use the raw, unstructured data using different algorithms, which again, we're going to discuss in this course. Also data mining and also predictive analysis. And data science also by Harvard Business Review stated that it's the sexiest job of the 21st century. Now, what is data science? Here we say data science is the adaptive, interactive, and also phased approach to the analysis of data performed within a systematic framework that uncovers optimal models by assessing and also accounting for the true cause of prediction errors. So here we can say data science is about, again, analyze a raw data set. This data can be structured or unstructured, very large data set. The concept of data science also comes with the big data analytics. Also, it's a combination of using statistics techniques, computer science techniques such as programming algorithms, machine learning algorithms, etc. And the main goal of data science is to discover knowledge in a large data set or a pattern in a large data set. So we say data science allows us to extract knowledge from databases. Also, it lets people leverage large amount of data and computing power to tackle complex questions. The patterns can arise which could not have been uncovered otherwise. These discoveries can lead to a powerful results. Now, data science applications are in different domains, different business, engineering, medicine, etc. So example given here can be, we can use data science application in banking industry such as finance, also public policy, politics, government agencies, healthcare, urban planning, education, libraries, etc., engineering fields, etc. And data science methodology, here we are going to use the CRISP data manual, which is the cross-industrial standard practice for data mining standards. And in this case, we shall see this. Each in data science methodology, we have different phases. So for example, we're always going to start with the problem understanding phase. This is where we are going to formulate our objective, what we really want to do, what is the problem. And we also here, we need to know if the problem can be solved by using data science techniques. So first is our problem understanding phase, then data preparation phase. Again, in the we are going to discuss in detail on each phases in our next slides going. So first we start with the problem understanding phase, data preparation phase, exploratory data analysis phase, setup phase, modeling phase, evaluation phase, then deployment phase. So again, let's go through each phase. So we start with the problem understanding phase. Here we say that teams often work hard to solve a problem, only to find out they solve the wrong problem. Also initiate project objectives. And here we need to translate objectives into a problem that can be solved using data science. Again, we may have many business problems which data science cannot be used. So again, in phase one, our main goal is the problem understanding, and also to make sure this problem can be solved using data science. Then next, we need our data. Data science is about analyzing data. So next, we may have data, again, structured and especially unstructured data. This data may consist of errors, losing numbers of values, etc., outliers. So normally we need to prepare the data for analysis. So phase two is data preparation phase. Here we say raw data from data repository needs to be cleaned. Probably this will be the most labor-intensive phase. For example, in data mining, we always say that 60% of the data mining work, between 60 to 80% actually, about data mining work is performed during the data preparation phase. Because if we don't have a good data, then we are not going to get a good result. The same thing applies with data science. The data preparation phase is one of the intensive phase. Here we need to identify any outliers. Outliers are very important because, for example, if we have a data set and one of the attributes, let's say salary, a person have 10,000, another person make 1 billion, we can see that the difference between the two values is too large that uh, 10,000 with 1 billion, 10,000 will not make any effect on 1 billion. But we can solve this problem by transforming the data, for example, using a log ratio. So in this case, we can find, let's say example, we can find a log base 10. So log base 10 of 10,000 will give me 4. Then log base 10 of 1 billion will give me 9. So here we can see 4 and 9, the difference are not too much. So we can work with that. So data preparation phase is very important. So transforming and standardize the data. So what we did with taking the log base 10 of each value is transforming the data. And the most basic techniques we can use is the log system to normalize the data. But again, there are so many algorithms that we can use to transform the data. We may discuss that in the future. For example, also discretizing values or for example, age. We have 100 patients with different age. Now, if we want to standardize this age, we can say, okay, between the age of 0 to 20 is 1, 21 to 40 is 2, and 41 to end is 3. So this time, instead of entering different ages, I'm going to use only 3 values, 1, 2, 3, to represent over 1,000 or 1 million patients age. So this also will be a concept of transforming the data. So we can also reclassify our categorical variables. We can use the concept of binding numerical variables and adding an index field. Again, we may discuss this in our future lectures. So step 3 will be the exploratory data phase. This is where we can use the basic data analysis techniques, even statistics. The goal here is to understand our data. Maybe we may find the mean, median, mode, standard deviation to see how the data varies, etc. So here we say we begin to explore and learn the basic information, in this case about the data set, not the time for complex algorithms. Also here, can learn quite a bit. Exploring univariate relationships, we can find a mean, median, mode. Exploring multivariate relationship among variables, maybe we can find a correlation if there's any relationship between variables. And also we can do the binding based on predictive value. Or we can also derive a new variables from an existing variables. Again, in Unit 4, we are going to discuss about exploratory data analysis techniques. In step 4, this is where we set up the system. So we set up the setup phase. Here we are almost ready. We have to get our application ready, the algorithms, etc. we're going to use. So here we say, since we have already prepared the data, the next move is to analyze the data. So here we have to discuss what algorithm we are going to use and what method we are going to use. So this will be We need to take care nearly ready to model. We need to take care of cross-validation. This is necessary to avoid, again, data dredging. We may discuss this in data in future. Also, data partition need to be evaluated. Also, balancing the data. We can enhance the ability of certain algorithms. We can also establish a baseline performance so that we can calibrate our models and also determine whether they are any good. This will be covered again in Unit 5, preparing to model the data. Then we're also going to establish the baseline performance so that we can calibrate our models and determine whether they are any good. This also, again, Unit 5, we're going to discuss it. Now, in our next modeling phase, which is number 5, here we are going to apply the algorithms to uncover a relationship in the data. For example, we have different types of machine learning algorithm. If we are doing classification or supervised learning, we can use algorithms such as decision tree, neural networking, support vector machine. So based on the type of data we have, the largeness of the data, if the data is very large or small, we may decide what algorithm to choose. Also, the type of variables we have, whether it's categorical or numerical values, etc. So here we select again, implement our appropriate algorithm. Inappropriate techniques, of course, will lead to inaccurate results. We also have to make sure that our models outperform the baseline models. We also have to fine-tune our model algorithm. Here we need to spend time for fine-tuning models before arriving at the optimal solution. And this Unit 6 up to the end of the chapter, which will be Unit 14, we are going to discuss about different types of data science algorithms. So the next will be evaluation phase. So anyone can make a prediction. How did the prediction perform against the real data? So here we need to assess how models are doing and whether we need to go back and try to improve. Our models need to be evaluated against the baseline performance measures from the setup phase. Also, we need to determine whether our models are actually solving the problem at hand. Then possible, we are going to apply error cost intrinsic to the data. Because data-driven cost evaluation is the best way to model and not the actual costs involved. We are going to cover this concept in Unit 7, which is Chapter 7 of our course textbook. And the last phase will be the deployment phase. So here we are going to report to the management on our best models. We are going to work with the management to adapt our models for deployment. So we need to write a report, a simple example, stay involved with the project, and also we need to participate in the meetings and process involved in model deployment so that they stay focused on the problem at hand. So we know data science methodology, again, as we said, is interactive and adaptive. In terms of interactive, sometimes it's necessary to return to the previous phase based on the knowledge gained in the current phase. So that's why, again, adaptive. So there are arrows pointing both ways between most of the phases. So we can see in each phases we have the arrow going opposite direction, point both phases. So it can be adaptive and also it can be interactive. So the model we created serves as input to the investigation of related problem. The outer ring of arrows shows a recycle of the older models used as inputs. Now, next we go to the data science stacks. As we said earlier, the three major algorithms faced in machine learning is supervised and unsupervised learning. Then we have the reinforcement learning. So this data science stacks falls on both supervised and unsupervised learning. So we have description, estimation, classification, all these three, and prediction. They are all supervised learning association. Then cross-storing is unsupervised learning. So next, we're going to describe what each of these stacks represent. So let's start with description. Here we say data scientists describe the patterns and trends. So describe a cluster of customers most likely to leave our company's service as those with high usage minutes and high number of customer service calls. Now, working with the marketing team, the analysis then can suggest possible intervention to explore in order to retain such customers. Another example in the widespread use around the world. For example, when a sports announcer states that a baseball player has a lifetime batting average, which is hits at bats of 0.350, he or she is describing this player's lifetime batting performance. So again, almost every chapter in the textbook contains an example of description task. Now, next is the estimation. Estimation also is used in statistics. So estimation is the approximation of the value of numerical target variable using the predictor variables. It's built using records where the target values are known. Models will learn which target values are associated with which predictor values. The estimation models can estimate the target value for the new data for which the target value is unknown. This also requires, again, the target variable being numeric. So estimation, our variables have to be numerical variable or quantitative variable. Next will be the classification. So classification, again, is similar to estimation, except target variable is categorical. So example would be a decision tree. Do you have a cancer? Positive or negative? Yes or no? True, false. So we can see that our target variable is categorical. True, false, positive, negative, etc. So perhaps the most widespread task will be mortgage lender interested in which of their customers is likely to default. So this can be default, yes or no, the outcome. It's categorical. The models show complete record of actual default status of a past customers. Learn which attributes are associated with customers who default. Then we need to deploy to a new data that will help classify customers most likely to default. So this is why classification is called supervised learning. We have to have some previous data with a known result, which we normally call the training data. Then we have to use it to, again, build a model in order in the future to be able to predict. Again, we may discuss more detail on classification algorithm in our future lectures. So next is clustering. Clustering is the unsupervised learning. So here we're going to identify groups of similar records. So if we have a group that have similar categories or values or records, then we cluster to them as one. If the group have dissimilar records, then we put them in different clusters. So identify groups of similar records. Records in a cluster are similar to other records in the same cluster, but different from the records in other clusters. So example, finding the workable clusters is useful in at least two respects. Your client may be interested in the cluster profiles, that is detailed description of the characteristics of each cluster. And the clusters may themselves be used as input to classification or estimation model downstream. So next is prediction. Prediction is similar to estimation or classification because prediction also is called supervised learning, except that for prediction, the focus is related to the future. So for example, here, financial analysis may be interested in predicting the price of Apple stock 3 months down the road. This will represent estimation since price is numerical variables, and prediction because we are looking into the future price. The next is association. The goal of association is to determine if two items have any relation or associated. So here we're going to determine which attribute associated with which other. So for example, if a customer buy product A, he may buy product B. So it's product A leads to product B or product C. So we want to know the relationship. So here we're going to uncover this relationship are called the rules. So here we're going to uncover rules for quantified relationship between attributes. Now, association rules take the form of if antecedent, then consequent. So if S equal to 10, then Y is 5. Or if product A is bought, then product B will be bought. So product A will determine product B. So product A will be called antecedent, and product B will be called consequent. Actually, this will be the last chapter of our course textbook. We are going to cover the concept of association. So what is the profile of a data scientist? Here we stated the 5 main set of skills as a data scientist we should know. First, quantitative. So we must have the skills of analyzing data, statistics, hypotheses, etc. Also, we need to be curious and creative, communicative and collaborative, skeptical and technical. So here we say the quantitative skills such as mathematics and statistics, technical aptitudes such as software engineering, programming, and skeptical mindset and critical thinking, ability to examine work critically. Curious and creative, we should have a passionate about data and finding creative solutions. Communicative and collaborative, we should be able to articulate ideas, and also we should be able to work with others. So that will be the conclusion of chapter 1 of our course textbook lectures. Again, see you in the class, and thank you for your time.